Okay, so we will continue looking at these linear transformations, which we now know any linear transformation has a matrix representation. And what we want to think about is what effect, if we're looking at maps from R2 into R2, what is the geometric interpretation of these linear transformations? And one point that I want to make that I didn't make in the other cases is that recall that any linear transformation T has to map the zero vector to itself. So in all of these maps, the origin isn't moving anywhere, but what we're doing is we're stretching, reflecting, and so on with kind of, you can think about putting a pin right here at the origin because that's not changing, but all of these other points are being stretched or rotated or reflected around in the plane. So this matrix over here is now not a diagonal matrix. So we have an entry over here, which is 0.75. So if we want to think about how is this map, first of all, acting on our standard column vectors, well, this is telling us what the image of E1 is. It's 1, 0. So in other words, we're not doing anything in the x1 direction. So here's the vector 1, 0. It doesn't get mapped anywhere. This second column, which is 0.751, that's telling us what is the image of the second standard column vector. So this vector E2, which is 0, 1, it gets mapped now over here to 1, 0.75. Or excuse me, 0.751. So what's happening is each of these points are getting shifted over diagonally to the right. And let's take a look at what happens to this elephant when we do that to every point on the elephant. So now this elephant is kind of getting stretched diagonally out, in this case, in this direction over here. And it's getting stretched in this direction over here. So we call this a shear transformation. And there are all other types of shear transformations. So again, I would encourage you to take a look at the textbook and play around with some of the different examples in the textbook. And your next Python lab is also going to involve applying some transformations to this same elephant. So you'll get a chance to play around with Python and see what different matrices do to this elephant. Okay, so let's take a look at one last type of linear transformation that's working from R2 into R2. So all of the previous transformations that we have applied to this elephant, in the end, we still have wound up with a different looking elephant, but it's still an elephant nonetheless. And here we'll see we have some different behavior that's going to happen when we apply this map. So this map, which is defined by this vector, this matrix A, right? A has its first column of 1, 0, and the second column of matrix A is 0, 0, right? So there's no pivot in column 2 of this transformation matrix. So this first column tells us where E1 gets mapped to. And so E1, the first standard column vector, is going to get mapped to itself. So we're not changing the x1 coordinate. T of x2 is getting mapped to the 0 vector. So when we are working with linear transformations, again, we know the origin, the 0 vector in this case, has to get mapped to the 0 vector. But there could be other vectors in addition to the 0 vector that get mapped to the 0 vector as well. And this would be such a case. So this vector, which is E2, is now going to just get collapsed down to the 0 vector. And so let's see what effect this has overall on the elephant. Well, this elephant now has disappeared, right? So this is what we would call a projection. And what we've done is we have taken this elephant and we've collapsed it down onto the x X1 axis. So over here, what you're looking at, this red dot, is the eyeball of the elephant. So the elephant is now flattened, and we've flattened it onto the X1 axis. So we've flattened it in this vertical direction, so we've collapsed it down onto now just, it looks like a line on the X1 axis, and it doesn't look like an elephant at all. Okay, so this is the last of the kind of geometric interpretations that I want to talk about. The textbook has a really exhaustive list of all of these. And again, look for the next Python lab where you're going to play around with moving the elephant around in R2.